Okay, let's look at 41 here. Now, this one's a little different. We have, if you look on the left side, I've got two logarithm terms, we call it over there. And we do have a log on the right-hand side now. So this is a little different than the last one. Plus, we're adding in between. So this is going to use kind of that first property of logarithms. We're going to condense this left side that I underlined down into one single log, which means I need to multiply these two. So that's going to be the log in base 5. So we're really taking x plus 13 and we're multiplying it times this thing over here, which means I distribute the x. So it would be x squared plus 13x. Now I'm going to put that in parentheses because I have two terms there. It's a binomial. And then on the right side I've got the log of 68 in base 5. So this is different than the last one because in the last one on the right side I didn't have a logarithm. So then I had to go to my exponential form if I don't have a log on the right side and just say, okay, this is equal to this base to whatever that thing is, that number on the right hand side is. Excuse me. When you have logs on both sides though, now you can kind of just drop the log, and they have to be in the same base, and they will be. We can just drop the logs off and we say x squared plus 13x has to equal 68 then. This has to equal this. We're kind of just dropping the logs off. Now this is quadratic, so I've got to set it equal to 0. So I'm going to subtract 68, set it equal to 0. Okay, now I'm going to factor, so I want a product of negative 68. I want a sum of 13. And you got to go through, 68's got a few products, but the two numbers are 17 and negative 4. Okay, so now this is where a is 1, so I can go right into just my two binomials, kind of use the little shortcut, and say it's x plus 17 and x minus 4. So if I set that equal to 0, I'm going to get x equals negative 17, and I'm going to get x equals positive 4. Now, we have to check these solutions. When I talked about extraneous in my last example, so I've got negative 17 and 4 that I have to check. Right away with this one, if I put negative 17 back into the original equation, no matter which side I put it on, here I'd go negative 17 plus 13, I'd be taking the log of negative 4. Well, that can't happen. And notice if I put negative 17 over here, I'd be taking the log of negative 17. So this one right here is what we call extraneous, and we have to throw it out. Now, 4 works because I'd be taking the log of 4 or the log of 4 plus 13 or the log of 17. So that one checks out. So the only answer I give for that one is 4. Let's go over and do 42 now. Okay, so let's look at 42. So now I'm going to use condense this side over on the left to a single logarithm. It's subtracting log, so I'm going to say it's the log of x plus 6 over x equals the log of 55. And we are in base 8 on both of these. So now I got logs on both sides, so I don't have to go my logarithmic form to exponential form. If I didn't have a log on the right side, then I would have to go through and do that. So like, if you look on 44 here, you don't have a log on this side, then you're going to go to exponential form and just form your equation. Now I can just drop the logs off. So I say x plus 6 over x is equal to 55. I'm going to make a proportion. I'm going to cross multiply, so 55x equals 1 times x plus 6, which is x plus 6. Got x on both sides, so I'm going to subtract x. It's 54x. It's equal to 6. I'm going to divide by 54. Slide down here a little bit, so I get x is equal to, that does simplify, 6 goes into both of those, so it's 1/9. Now we just got to check and make sure it's not extraneous. If I put 1/9 in here, 1/9 plus 6 would be the log of 6 and 1/9. It's a positive, that's okay. And I could take the log of 1/9. As long as that's a positive number right there, it's okay. So that checks out, and there's my answer.